So we have a few more examples. A book club offers a choice of 8 books from a list of 40. Assuming order doesn't matter, and how many ways can a member make a selection of the 8 books? So because it says assuming order doesn't matter, I can automatically assure that this is a combination. I have N and R. The N is 40, and I'm choosing 8 from those. So we have our formula 40 factorial over 40 minus 8 factorial times 8 factorial. That means we have 32 factorial on the bottom, which means we're going to have a long list here. We have 40 factorial, which is going to be 40 times 39 times 38 times 37 times 36 times 35 times 34 times 33 times 32, and now I can stop because 32 factorial is also appearing in our denominator. Ooh, that was a lot of writing. But I still have 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. The 32 factorials divide out nicely, which is helpful. Now I'm going to type it in the calculator. Parentheses 40 times 39 times 38 times 37 times 36 times 35 times 34 times 33. Parentheses divided by parentheses 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Close that parentheses. This gets me an answer of 76,904,685 different ways you could pick the 8 books from 40. That's a lot of different ways to pick. Other ways you could type it in the calculator, if you had a factorial button only, you could type 40 factorial divided by parentheses. You'd have to put parentheses around the denominator. 32 factorial times 8 factorial. Close that parentheses, and you'd get your same answer. The third way you can plug this in the calculator, if you had the function, is just to do 40 choose 8 using the combination function, and you still get the same answer. Okay? But you will have to show some work on the test. Our next example, in January 2017, the U.S. Senate consisted of 46 Democrats, 52 Republicans, and 2 independents. How many distinct 5-person committees? Okay, committees. What does committees tell us? Committees are combinations because everyone's working together on the committee and no one has a different position. So that's not going to be a permutation. It's definitely going to be a combination. So how many different 5-person committees can be formed if the committee must have 2 Democrats and 3 Republicans? Apparently no independents get to be on this committee. So in this case, I have 2 different things that are going on. I'm going to be using the fundamental counting principle and finding out how to get 2 Democrats, and we're picking from a list of 46, and then we're going to be multiplying that by 3, the number of choices of 3 Republicans, again from how many Republicans? 52. Okay, so I am going to be choosing 46 choose 2, and then I'm going to multiply 52 choose 3. So we're choosing 3 Republicans from 52, and we're going to multiply that by 2 Democrats from 46. Now I'm going to use my formula. We have 46 factorial over 46 minus 2 factorial times 2 factorial. The second one, we have 52 factorial over 52 minus 3 factorial times 3 factorial. So 46 factorial, and I have 44 factorial times times 2 factorial. On the Republican side, 52 minus 3, that's 49 factorial. So I have 46 times 45 times 44 factorial. I'm going to stop at 44 factorial so that the 44 factorials will divide out. Then we have 2 times 1 on the bottom. 52 times 51 times 50 times 49. I'm going to stop at 49 factorial so that the 49 factorial on the bottom divides out. The 3 factorial I'm going to write out nicely. So the 44 factorials divide nicely, the 49 factorials divide nicely. So now I'm left with multiplying. So one easy way we can do this is I can think of every single term in the numerator, 46 times 45 times 52 times 51 times 50, as one big numerator with one set of parentheses around it. I can think of everything else in the denominator as one denominator because they're being multiplied and with one set of parentheses. So if you didn't have any factorial buttons on your calculator, you'd do it the long way. 46 times 45 times 52 times 51 times 50, close that parentheses, divided by, open up a new parentheses for the denominator, 2 times 1 times 3 times 2 times 1, close that parentheses, and that gets you 22,873,500. These are the total number of ways you could pick a committee, a 5-person committee, with the requirements that you have to have 2 Democrats and 3 Republicans. Now, if you had a calculator that has the factorial button, you could instead use this function right here. We'll put a parentheses around the denominator, put a parentheses around the numerator, and then just use the factorial button. So 46 factorial times 52 factorial, close that parentheses, divided by, open up another parentheses, 44 factorial times 2 factorial times 49 factorial times 3 factorial, and close your parentheses, and that still gets you the same exact answer. And if you really want to check your work and you have a calculator that has this function, you can type 46 and choose a R using the combination 2 times 52, choose 3 if you have that in your calculator, and you still get the same answer. So no matter what type of calculator you have, you should be able to multiply this out and get your answer. Definitely wouldn't want to do this without a calculator, but several different ways of typing it in. And that concludes our lesson today on combinations.